formula says that if I have cosine of a plus b, so here's a sum formula. So I had cosine of, let's scroll down a little bit. So cosine, if we just look at cosine of 75, if we look at the quadrant 1 value, that's cosine of 45 plus 30. So this formula says that we've got, let me just take a little picture. Paste it in. All right, so this formula says that it's going to be equal to cosine A times cosine B, so cosine 45 times cosine 30, cosine of 45, this is 105, so we've got our negative version. But remember up here, we had our negative outside of all of it. So if we had stuck with our original, then we would have had the parentheses here. So we're looking at 75 instead of 105, which we're making negative. All right. So minus, notice it's plus minus, so I have plus up here, but minus plus over here. So now I have to go minus sine of 45 times sine of 30. Let's pretend that I wrote what I said. All right, so that's root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. We wanted cosine of 105. Cosine of 105 is negative of the cosine of 75. So that means it's the negative of this, making this part positive, and this part negative, which is exactly what we got over here. So it is possible to draw sum and differences, to make a bunch of triangles and rectangles, but boy, is it a hassle. And instead, we can use these compound angle formulas. So all of these can be proven, and if you want to see the proofs, I have some nice ones that don't use any angles. They don't use actual angles, they just use variables the whole time to prove them, but you're never going to be asked to prove them even in higher level. You're just going to be asked to use them. So that's what the next examples are going to do. I'm going to write up the solutions, or I'm going to write down the solutions for these. I have them drawn by hand, and I'll leave them hanging on the board if you want to see them, but feel free to try and draw these yourself. The 7 pi over 12, there's a hint there that 7 pi over 12 is the same as sine of pi over 4 plus pi over 3. And 19 pi over 12, well, that's of course pi, so we're going to take away a pi, and then I'm going to have a 7 pi over 12 left. So very similar over here, because 7 pi over 12 is these guys. All right, so try those out, but come back and we're going to look at using our formula to solve problems like this.